Namaskar. So let's see how we can interface an IO expander to a MCU using I2C interface communication technology. Okay. So we will be using I2C techniques to interface our IO expander. So basically IO expander we utilize to extend our number of GPIOs. Okay. So as you can see, we have MSP M0L1105. So it has very less number of GPIOs, around 16 or 17 are there, and we have very limited capabilities to utilize more IOs. Okay, so for that purpose, we try to utilize another expanders, and it will increase the number of IOs. Let's say this is the device that I am using, which is having 16 IOs extra, right? Port A and port B, both of them are having 8 IOs. So our aim would be to try to, communicate this expander to the MCU. Okay. So IOs will be having same functionality as my microcontroller IOs will be having. The technique that we are going to use is I2C. So what is the thing that we have already done? We have I2C SDA line and we have I2C SCA line, that is clock line. Okay. So as you can see, I2C SDA and I2C SCL both are pulled up with 4.7 kilo ohm. So first of all, what we'll do is we'll try to understand what is the part that we have chosen, and what are the features or all the other things that is available with this, right? So the part number that we have chosen is MCP 23017-E/SO. Okay. So this is from microchip and it is having 28 SOIC package. Okay. So I will be using this package, 28 SOIC package, and you can see we have VDD pin, that is power supply pin, VSS pin, that is ground pin, it is also power supply, means ground, and we have two non-connected pins, NC 11 and NC, that is pin number 14, and we have two lines, which is SCK line and SDA line, that is our interest, which is I2C lines. So we will be communicating through this whatever the position that we want for all the IOs. You can see port A is 8 pins and port B is also 8 pins. So suppose you want to make GPB0, that is state 1, means high. Let's say you want to make it high. So for that you have to write I2C communication for this particular bit 1 and it will be made 1. Okay, this is how. Even it can work as input, so we will have to define the direction and then we will have to understand it. So let's open the data sheet for this particular IO expander and we will see the features, and after that we will design the circuit. Okay. Okay, so I have opened the data sheet for MCP 230 17. Later I will discuss with another device which is which is having let me open again. Okay, so what we are going to see is here we have 16-bit IO expander. You can see it is AEC 100 qualified. Okay, and it is 16-bit remote bidirectional IO ports that I already told you. Okay, and then it has the capability of 100 kilohertz, 400 kilohertz and 1.7 megahertz, and we have seen already that our microcontroller also I2C interface is also having the same capabilities. Okay, so there is no need to worry about. It has SPI interface, but that is another series which is 23S17. Okay, so that we will talk later. Okay, but we will stick to right now MCP 23017. Okay, 23017 device. Now next is we have interrupt A and interrupt B. As I already told you, this can be utilized for interrupt functionalities, but right now you'll be not using that. Next we have operating voltage. So operating voltage, you can see it can work from 1.8 volt to 5.5 volt, minus 42 85 degree centigrade. We will stick to this voltage range device, and the device that we have selected is 28 pin SOIC. Okay, so this is the pin that we have selected, and this is the device that I was showing you. Let's now move to the design process. So first of all, I'll directly move to here. This is the pin description. So pin description, as you can see, it's very easy. We have general purpose, like input output pin B0, B1, B2 up to B7. Okay, and similarly we have GPA0 to A7. Okay, so these are the 8 pins plus 8 pins. Total 16 IOs are there with us. Input output direction, and this is the pin number of SOIC, like package type. So SOIC package type will stick to that. Okay. Next we have VDD power supply and VSS ground, and we have NC, okay, which is having chip select also functionality that we'll see later. Pin number 11. Okay. So if you want to, like cascade some of the device, that is little complex. Like we can make some up to 8 devices, like communicating through I2C lines. So that we'll discuss little later. Next is we have SCK lines and like SDA lines, so that we have to connect to our I2C lines and address lines. So let's directly jump to the functional block diagram. So what happens to the functional block diagram? As you can see, uh, these are the like port pins that is available. These are SDA and SCL lines that is communicating through I2C technology, I2C communication interface, and we have address pins that is A0 to A2. So if I take up A0 or A1 and A2, so 000, so that will be first device. Second device, that will be 001, 00010, like that up to like let me make it 0. So like that we can add up to 8 devices. So based on the like address, we can connect 8 devices. So right now our aim is to connect only one device. So any address you can write down, this will be selected by default. Okay, and we have reset and we have interrupt. Next is I will tell you quickly how we can like define the product identification. Like if you want to order the part number, so we have MCP 23017, that is I2C interface, and S17, that is SPI interface. Okay, so we will stick to I2C interface one. Next, if it is blank, then it will be like optional. Otherwise, if it is T, then it will be tape reel. So I will be putting without this T and with this T, that is tape reel. So I have taken without that one, so no problem. Any of this is fine. So MCP 23017 dash E/SO. Okay, that's good. If you take E, then it will be extended temperature, that is -40 to 125 degrees centigrade. Okay. All right, and SO package and all those things. So you have understood the like device parameters and device features, right? Now let us move to design of this. So as I already told you that we have like I2C SDL SCL line. So I2C SCL line, I'll connect it to SCL line of this particular device, and I am going to remove this particular like resistor. Okay, because I already have put one resistor here in the microcontroller, 4.7K 4.7K. So the I2C communication lines are already pulled up, so there is no need to pull up again. So I'll put it DNP both. Okay, this is the way you have to like design your circuit. Okay, otherwise I have kept the provision here also, so that if the I2C lines are not pulled up in microcontroller side, then it will be pulled up here, so both will be having same job. All right, so I2C SCL line is done and SDA line is also connected. So data line and clock line is connected. I have given a 100 ohm resistance in the middle, so that there will be like a proper functionality. Next comes up is VDD line. So VDD line I have supplied 3.3 volt with a like decoupling capacitor of 0.1 microfarad. I am not using interrupt functionality right now, so I have left them blank. Okay. Coming to the part of biasing of this address lines. So what I have done is I have connected like a high to the address line A0. So it is like, let's say A0, A1, A2. So I have connected 1, and then A1 I have connected upper one is DNP, lower one is connected, and lower one is again connected for A2 also. So both are DNP and both are connected to the ground. So it will be 0 0. So my address line is actually 0 0 1. Okay. So whenever address line is seen 0 0 1, this particular device will be selected and the communication will start. Okay. Next, another part was to the VSS pin that is grounded, and NC pin was not connected. Okay, that's fine. Coming to the fact that reset pin. So what I'll do is I have put one extra, like a switch here, a push button switch, and it is pulled up high. So once it is, this particular switch is pressed, it will get grounded and the device will reset. Okay. So if there is, like any corruption of the, like data or anything happens, then you can reset the device. Again, it will start fresh. Okay. But it must be pulled up for the device to work, fine. So this is how we had communicated. Again, some of the, uh, I mean, iOS I have connected already here. So what you can see is we have, let's say, select. So you want to select something by, putting it high or low, then this line can go to that particular circuit. If you want to drive some, or read some data of push button switch, then user PB0, user PB1 is connected here. So I'll just open the circuit for you. Let us say I have, a user push button 0 and user push button 1, okay, connected here. Instead of connecting into it to the microcontroller, I'm going to take out from here and I'm going to connect to the IO expander. So IO expander is reading right now 1. Whenever this will be pressed, it will read 0 and that value will be communicated to the microcontroller. Understood? So this is how it will be working. Similarly, you can, drive some LEDs, LED 0, LED 1. So you can drive it, or it can act as a source also, okay, or sink also. I am taking, an indication of power good signal from a regulator. So my regulator is working really fine. So I am taking the status of that. So these are the pins that is actually acting as a IO pins to understand the status of the different parts of the circuits, right? So these are the things that will be used even in microcontroller IOs, right? Similarly, like I had to select a mode 0, mode 1, mode 2, mode 3. Three pins are there to select the mode of the programming. So these three facilities is also used. Similarly, other, 4 pins are used for dip switches. All right. So this is the way you can assign the pins. It's not that you have to assign these functionalities only, like based on your uses or your, requirement, you can assign those things. I will give you one simple example from the microcontroller pin itself. Let us say just now I told you that user underscore PB0 is connected here. Now instead of using this user PB0 here in the microcontroller pin, I can assign the same functionality to user PB0 here. This is how you can connect, okay, and there you can remove it. Okay, so this is how you have, got one extra pin here, and this is A8 also, so it is ADC pin, so you can utilize this pin for your ADC function. So this is the advantage of using your IO expanders. What are the more advantage that we use for IO expander is, let's say we have to connect some LCD which requires some 16-17 pins, right? And for that you need lot of IOs. So LCD connection, you don't want to waste your microcontroller IOs, and instead of that you will be using one IO expander. Similarly, you will be using for keypad, like you have a lot of, like keypad that you would have seen in your daily uses. Let's say like calculator is there, or maybe other keypads. You need, any machines are having, like a lot of keypads, maybe 10 keys are there. So for that you need 10 IOs. So for that IO expanders are also used. So hope you have understood how I have, like interfaced my IO expander using I2C communication interface to the microcontroller, right? And how I am putting the address lines as well, right? Now suppose you wanted to, like use one more same IO expander, so that you will have 16 plus 16, that is 32 IOs. What will you do? Here you are putting, like address line 1, next one you will put address line 2 or 3 or 4, like that. So up to 8 address lines you can utilize. It means you can use 8 like IO expanders like this. Okay. So let's go to the data sheet of this particular device again, and you can see we have maximum ratings and everything. So I have blindly put a 1.8 volt to 5.5 volt is already there. So I have blindly like taken the power supply as 3.3 volt. So that was really good. Understood? So this is the way you can connect your IO expander using I2C communication method. And if you do have any questions regarding this particular IO expander, one more thing I will tell you before concluding this session is this particular IO expander. This particular IO expander is very good. It has been taken from microchip, and this is very sturdy device, and it is used very frequently. I can give you some of the references from Texas Instruments as well. They are little lower cost. Okay. So if you do have any questions regarding any functionality or adding this particular lines to the microcontroller and this IO expander lines, and how you are going to assign these IO pins for what kind of functionalities, whether this particular functionality can be utilized or not in this IO expander GPIO instead of using the microcontroller GPIO, that also can be answered. So you do put your questions in the comment box, and I shall be able to answer you out. Thank you so much.